Dear students, I'm Dr. A. Juliet Christina Mary, Assistant Professor in the Department of Physics, Jayaraj Anabakim College for Women, Autonomous, Periyakkulam. In this session, we are going to discuss about free, forced, and damped oscillations. Before going to this in detail, we should know about what is oscillation, frequency, amplitude, and time period of oscillation. Assuming that a particle is oscillating, then we should know what is oscillation. Oscillation is a periodic variation in time of a matter about its mean value. One cycle of periodic to and fro motion of the body about its central position is known as one oscillation. Mechanical oscillations are also called as vibrations. A particle is vibrating means it oscillates between 2 points with respect to its central point. Then we should know what is about frequency, amplitude, and time period. The frequency of oscillation is defined as the number of complete oscillations per unit time. And the amplitude of the oscillation is defined as the maximum displacement of an oscillator from its equilibrium position. Then the time period of the oscillation is defined as the time taken for one complete oscillation in seconds. Then we should know what is the relationship between frequency and time period, which is represented as F is equivalent to 1 by T. Some of the examples of oscillations are the motion of a pendulum bob in a clock. It is repetitive motion with the bob rising to its right, coming back to its central position, again rising to its left, and finally going back to its center again. This total cycle constitutes one oscillation. And another example of oscillation is movement of spring, tides in the sea, the vibration of strings in a guitar and other string instruments, elastic media, and a sine wave is also a best example of oscillation. Then we should know about what is simple harmonic motion. Simple harmonic motion is represented as SHM. It is defined as a periodic oscillation of an unaltering frequency and a constant amplitude, where the magnitude of restoring force on the object is always acting towards its equilibrium position and is directly proportional to its displacement. It is an ideal condition where the displacement on one side of the equilibrium position is exactly equal to the other side. Based on the external forces acting on them, the simple harmonic motions are classified into 3 categories, such as free, forced, and damped oscillations. First, we will see what is free oscillation. Free oscillation or vibration, it contains a consistent period and amplitude without needing external force to set it. Herein, the vibrations occurs in the absence of friction and it produced when a body is disturbed from its equilibrium position. Generally, free oscillation does not go through damping. But in the region of all natural systems, the process of damping is observed till any consistent external force comes to overcome it. The solution to a free vibration is usually roughly a sinusoidal wave-like formation. Suppose if the repeated force occur on a mechanical system, then it is called as a forced vibration. This is the second kind of vibration. Herein, continuous periodic force is required to initiate the forced vibration. The forced vibration is equal to the external periodic force. The vibration of moving vehicle is an example of forced vibration because the vehicle, the spring, and the road, etc. continue to make it vibrate. Then vibration is always expressed by the unit of velocity, displacement, frequency, and acceleration. SI unit of vibration is watt per meter square. Suppose if the driving force equals the natural frequency, the amplitude of oscillation reaches a maximum. That frequency is known as resonant frequency and the curve is known as resonant curve. This is the example for forced vibration, and this resonant curve shows that the external frequency and the natural frequency matches. The amplitude of the frequency will going to a maximum value. This value is called as a resonant value. From the resonance graph, it can be seen that the amplitude of oscillation at all frequencies is reduced. The frequency at maximum amplitude shifts gradually to the lower frequencies at each side. Damped vibrations are periodic vibrations with a continuously diminishing amplitude in the presence of resistive force. The frictional force or resistive force act in the direction opposite to vibration. Damped vibrations are a subset of forced vibrations where the force is applied to resist the motion of the system. This is an example of damped oscillation. Initially, the amplitude of the wave is very high, at time increasing, and also due to the application of resistive force in the system, the amplitude of the wave will be slightly decreasing. At the end of the time, the amplitude of the wave will be dead. Based on this damping position, this damped oscillation can be classified into two categories. One is critical and over damping point. When the displacement decreases to zero in the shortest time without any oscillation is called critical damping. In the graph, the pink color one represents the critical damping position. Any damping over the critical point is called over damping point. From the graph, the blue color one represents the over damping point. Displacement decreases to zero in a longer time than for critical damping. Suppose if we consider a spring which is having a mass m, now the spring is being elongated, the spring starts to vibrate with some certain frequency. That frequency omega be denoted as root k by m, where k is the spring constant and m is the mass of the spring. Suppose if the simple pendulum, consider a simple pendulum, the bob is hanged at the length L, then the natural frequency of the simple pendulum omega be equivalent to root of G by L. Now the simple pendulum is slightly oscillated. At a particular time, the oscillation will be damping. Then the damped oscillation frequency will be denoted as omega D, which will be equivalent to root of omega naught square minus B by 2m the whole square. Some of the examples of damping oscillations, which are shock absorber dampers on car for pumps, and another one is spring doors have dampers to slow their closing. Now we will see the difference between free and forced vibrations. Free vibration, when the body gets disturbed during its equilibrium position, it produces the free vibration. In the case of forced vibration, when external periodic force acting on a body, it produced forced vibration. The force is required to initiate the free vibration, but in the case of forced vibration, continuous periodic force is required to initiate the forced vibration. Free vibration is a self-sustained vibration. Herein, forced vibration is an externally sustained vibration. Free vibrations always depend on the body, hence it is also called the natural frequency. The forced vibration frequency is equal to the external periodic force. Free vibrations are stopped rapidly, but the forced vibrations are stopped based on the external periodic force. Example of the free vibration is the simple pendulum oscillation. For the forced vibration, the example is music instruments that have soundboards. Hope you all understand about free, forced, and damped oscillations. Thank you.